Hi, everyone. Bonjour à tous, and welcome to another Forward 50 session with one of our sponsors. In this case, our partner is Amazon Web Services. AWS, as they're better known, is obviously the leading provider of cloud computing infrastructure. And they've done some amazing things in the last few months in terms of scaling up pandemic response and emergency support. And I'm really happy to have with me the country manager for Amazon's public sector, Rejean Bourgault. Hey, Rejean, how you doing?
Bonjour, Alistair. I'm very good. And you?
Très bien, merci. On va le faire en franglais d'abord.
Bien sûr.
Alors, je sais qu'il y a quelques semaines, je parlais avec Pia Andrews, qui a géré la plupart de la réponse SERB pour le gouvernement. Et je sais que c'était une expérience sans pareil, je dirais, pour voir les personnes dans le service public agir avec une vitesse qu'ils ne pensaient pas qu'ils le pouvaient. Est-ce que tu peux me parler un peu de l'infrastructure que vous avez mis en place pour ceci?
Oui, bien entendu. Donc, pour le Canada Emergency Response Benefit, le programme SERB, on a travaillé étroitement avec ESDC et ce qu'on a fait pour eux, c'est d'établir un nouveau contact center, so a brand new contact center using Amazon Connect, where we basically built just in a few days, 1,500 contact center agents. And what we observed with the ESDC on this one is we were having an average of 27,000 calls a day in the month of April, and with some peak at 40,000. So the beauty of the service is we were able to help citizens that were unemployed and were trying to get access to tens of billions of dollars. That was a safe line for them, and we believe we were part of the economic recovery for Canada helping ESDC. So that was a very close work with a partner of ours, which is Accenture in this case.
And I think it really underscores the difference between traditional infrastructure and on-demand computing. It seems like this is exactly the kind of thing cloud computing was designed for, right?
Absolutely. And this is the same technology we're using for Amazon Retail for the agents that we are using for our own Amazon. This technology that ESDC is using can scale up and down based on the demand. So it's very, very easy to go up to 5,000, even more agents, and just scale down and when they don't need it. So this is definitely using the power of cloud and the elasticity and the agility. And this one, we were very proud because we were very tight and just seriously, it took 4 days to set it up the day we got the go for April 6th start date.
So, I mean, I think everybody would agree that developing an application quickly and spinning it up into the cloud when it's something like SERB makes sense. But there's still generally this resistance to using it for like long-term production workloads that people know will stretch out for years. Do you find that's changing? And like, if you were talking to a CIO, what would you say to convince them that cloud computing isn't just for on-demand spiky workloads, but can also be used for more in production workloads?
Oh, we have many, many example in this. And if you look at what happens in the last 6 months, the pandemic crisis really accelerate the government and become an early adopter of technology. We've seen it in education, in healthcare. I can give you an example of Athabasca University that migrate all in on AWS this year. So they complete their all in, they move their learning management system, they move the entire ERP on AWS. And this is a long-term workload, and they're saving 16 million over 5 years. We're seeing a lot of SAP migration on AWS. Like we have over 5,000 SAP workload on AWS on a worldwide basis. Right now, today, just to give you a perspective, we have 6,500 government agency around the world, 11,000 academic institution, and over 29,000 non-for-profit. And in these different organizations, they're moving a very significant workload.
So I think another misconception that people have about cloud computing, because the word computing is in there, they think of it as just containers, right? And I remember in the early days of cloud computing, we talked about if it's infrastructure as a service, then you're moving the compute workload. If it's a platform as a service, then you're moving the code And if it's software as a service, you're moving the content and the permissions. Last time I checked, AWS had more than a couple of services. You started with S3 for storage and EC2 for compute, but really today it's much more like you're choosing from an array of platforms, and some of them are, inherently containerized. Like there is an EC2 instance. It's a single virtual computing environment. But more and more, there are these other ways where you just write code and you don't have to worry about the underlying, how the sausage is made. Can you talk a little about the other services? Because I think things like CloudFront or Kinesis are not things that most people understand when they talk about cloud computing. They still have this mental model of containers.
Well, you're absolutely right on. In terms of when you look at it, AWS was created in 2006. And you're right, the two services you just named, compute and storage, EC2 and S3. And cloud computing is very misleading because it's much more than that. Today, we have over 175 services. Just to give you a perspective, we have 15 type of different database. One of the database, Amazon Aurora, is 1/10 of the cost of a commercial grade database, the same performance. Amazon, in fact, we turn off Oracle database last year. So we no longer rely on Oracle for database. We're using our own technology, Amazon Aura or DynamoDB for non-relational database that can do trillions of transactions per day. So that's one area. Machine learning and AI is another area that we're doing a lot of effort. We launched 2 years ago a solution called Amazon SageMaker. And the beauty of Amazon SageMaker is now giving the capability of developing AI model in the hands of software developer and engineer versus only in data scientists. And a very good example of this is during COVID-19, just before in January 2020, we launched the Cloud Innovation Center at UBC. And as soon as the pandemic started, they wanted to play a key role. And the role of the KIC was to look at social and well-being and health. And they jump on it and they say, hey, we have a research, we would like to leverage the KIC and your expertise and our experts and doctors and so on. And the students at the university and professor, and basically they create an AI model with many partners in the industry, including Element AI, to just name one. And basically, they collect from 6 countries around the world 3,000 CT scan of lungs that were infected by COVID-19. And they developed a model. They used tens of thousands of hours basically to annotate all these CT scan. And today you can go to the UBC KIC, you can run the simulation, and it will show you the probability that you have COVID-19. So basically a probability of that CT scan as COVID-19.
Yeah, I actually heard that in China, they were doing, if you had symptoms, they were doing a CT scan first. Like you weren't allowed to go home. When you were detected getting on a bus and having a fever or whatever, you went to a place and got a CT scan first. And then based on the scan, they then did the PSA and other tests.
Interesting. So basically, we're giving tools to doctors and we put it as an open source. It's also available on GitHub. So doctors around the world can use this open source that was developed with UBC. So this is just an example. So you mentioned what type of services. Yeah, we talk about database, we talk about machine learning, we do a lot of IoT, Internet of Things. There's some gaming software that we have.
Some gaming. I mean, there's Twitch. I think you may be underselling the some gaming, right?
Yeah, but Twitch is part of Amazon. But
Sure.
when I'm looking, if you look at the 175 services, we have some.
Wait, you have 175 services now. This feels like the old days of Java, when if you were a good developer of Java, you had that poster on your wall with like all the Java objects and properties and stuff. Feels like that. So how does someone choose which database to use? Because that's a lot of choice.
That's absolutely right. So those are purpose-built database. Some of relational, some of non-relational, like DynamoDB. But that's the thing, right? So when people start to learn about cloud, one of the things that they need, and this is why training is so important for government employees and any people who want to start their journey in cloud, is it takes a while, right? You're not starting with 175 services day one. I can give you a good example of that. Desire to Learn, which is an ed tech, which based in Kitchener in Ontario. When they started, they only use a few services, and it took them about 5 years to use up to 70 services today. But because they're engineers, software developers starting to build on different solution and say, hey, this is new, a new thing that we can start doing. Maybe we can attach a database. Maybe we can use this type of container. Maybe we can go serverless. So it just takes time where we provide the right training, and after that we bring our professional services team that helps with our solution architect, these customers, to get comfortable with the technology. And as soon as they start getting comfortable, it's a flywheel, it's a snowball, right? People start to learn more and more, and they see all the cloud services can help them. You talk about up and down and scale and elasticity. That's absolutely key. And I can guarantee you during COVID-19, the last thing you want is the information website to go down, right? So when you look at the key website, canada.ca, quebec.ca, and ontario.ca, they all run on AWS Cloud. And I can give you one
Are they
stat.
using CloudFront for the front end as well?
They
Like
are using
DDoS
CloudFront.
prevention and stuff?
Absolutely use CloudFront. And if you look at Quebec, and during the peak days, they were getting up to 2 million visits.
Wow.
And basically, you have Quebec.ca, but also you have all the different segments like Quebec.ca/coronavirus. So these type of website, they had a lot of traffic up and down. And the thing we like to do is help the IT director to sleep at night, right? So when you know that your infrastructure is going to follow the up and down of the demand, I think it's very important, and it proved the power of the cloud.
So I'm old enough to remember the days when resiliency was a vertical scaling thing. You went and bought a computer that had two power supplies, right? And you had redundant buses on the computer, and your switches are redundant, and so on. And that idea of just get a more reliable computer has been replaced by get a whole bunch of much less reliable computers. I heard, and you've probably heard this quote before, that like we used to treat computers like pets. We gave them names, and when they were sick, we brought them back to health. But now we treat instances like cattle, and when it's sick, you shoot it and you create a new one, which is a little rough, but it's definitely a different way of thinking. That machines are cheap, but architectures are what matter. Can you explain a little bit? Like I'm thinking about when you say a system can be elastic or resilient, there's lots of layers for a technologist to think about that. There's DNS, right? And then below that, there's your autonomous zones for routing. And then behind that, there's your instances that you're running that have some kind of a load balancer on them. And then you have a shared nothing architecture behind it so that if one instance fails, another one can pick up the session. Like, how do you get people to go from the old model of just make it tougher to tie a whole bunch of relatively fragile things together very well, and they'll actually be much more resilient? Because that's
Yeah.
another
So
like mental shift that I don't think a lot of people have about cloud computing.
well, one of the mental shift is to get away from server and your own premises, right? So we people love to hug, and you've seen these picture of server hugger, right? When you look at resiliency, look at the way we architect our region, and just take the region of Canada that we implement in December 2016. We now have 3 availability zone, and each availability zone we have multiple data center, and each of these availability zone are separate in distance, and they can offer a high availability. So the architecture is extremely robust, and that's one of the things that it's a haha moment for a lot of software engineer or architect that look at the technology on-prem, and then they realize how fast you can deploy these infrastructure. And sometimes we do demo there, and you can hear a pin drop because we said to people, how many instances you want? You want 100, 1000? And we just do the demo, and they see the speed of all these instances just go one after the other. One of an interesting fact, we talk about ESDC and the technology of contact center. We had a session, and one of our engineer asked someone, someone has a timer in this room? So someone raised an hand, I have a timer. Say, please start the timer. And he just went on and he built an entire contact center. And as soon as he finished, he asked the person, can you stop your timer? And the CIO just turned and said, how many minutes? The guy said 6 minutes. And you can hear a pin drop. Nobody was talking. And then at one point, the CIO said, where's the gotcha? I don't understand. How can you do that? And then we explain like the power of cloud. So resiliency is absolutely important, and it's one of the reasons customers choose AWS is the availability, the resiliency, and the agility of the cloud.
Yeah, I think a lot of people, in the old days, the cloud, I remember when virtualization started, it was like, that's what you do with your mail server and your print server because they're busy and you can combine them into one machine because machines are precious. And with a lot of the early adopters for cloud computing, it was startups, it was QA workloads. It wasn't production until people got a taste for it. But it seems like now when people are talking about cloud computing, the value is not just I can spin up an elastic workload. It's that workload will be more responsive because I'll have to get data from a nearby data center, or it'll be more resilient because there's no single point of failure. The thing that I always hear people question about clouds, especially in government, is data sovereignty, which is like, hey, I need to own my own data. It's not so much server hugging as data hugging. So can you talk a little bit about data sovereignty and like the kinds of protection you have for data exfiltration and migration and so on?
Yeah, first of all, security is job number one for AWS. And if you think about it, in the past, it used to be the conversation. I can say 3 years ago, most of conversation we were having were about is security with the cloud, do I have any risk, and so on. I can say that by the end of 2016, when we implement our region in Canada, that was also part of the reason for data sovereignty. Wanted to respect what the government and some agency wanted to make sure that the data stay in Canada at rest and also in transit. And when it's at rest, can I encrypt the data or even in transit? So today, I can say that from coast to coast, we have customers that use our region, and the data never leave Canada. So it basically stay in Canada in transit and also at rest. So security is absolutely our job number one. And I can say that now customers are really moving to how and when. And as soon as they understand the layer, the foundation, the compute, the storage, they very quickly realize that their engineer, they were spending way too much time fixing hardware, fixing, people on beeper at night, like, the famous people were having this on their belt, right? Checking, like, doing maintenance window at 3 o'clock in the morning. Like, we manage the infrastructure for them, and now it's a change. These software developer, they can really focus their energy on value add services, a value solution for the government, and building this application where they don't have to worry about the infrastructure. And I think that's very important.
Awesome. And I think that's a great place to leave things. We started talking about how cloud's elasticity was able to help government deliver things very quickly in an emergency. But it sounds like the nature of cloud is that once you're starting to do it, it actually helps you to restructure government for the 21st century and for digital government. So that's a nice way to tie things up. So Rejean, thank you so much for this conversation. It was actually really interesting. We have a lot of stuff ahead of us in the next few weeks before Forward 50 hits. Pleased to say it is going to be a fantastic event, and we're super happy to have Amazon as a partner and to have Mark Schwartz joining us to talk more about cloud computing and leadership and bureaucracy and all the things he's worked with. So really looking forward to seeing you at the event. Can't wait for it to happen. And thank you so much for spending some time with us today.
Merci beaucoup, Alistair. It was a pleasure today talking with you. Good luck.